Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome again to our YouTube channel today. So today we're going to look into chemistry, so grade 10 chemistry. So if you, in case you haven't subscribed, in end-term assessment 2026, in case you haven't subscribed, kindly do so right now. So let's start. Now, question 1. In Oltanki Senior School Lab, learners observed a certain atomic model. Three of the learners described it as follows. The center contains protons. A chain electrons move around it. It is Rutherford's model. Question A. Name the part labeled plus. Name the part labeled plus, and that is protons. It is protons. That's what most students could have written, but it's not the answer. Now the answer is the nucleus. Okay, the nucleus. Identify the particle labeled E minus. E minus. What's the E minus? Okay, identify the particle labeled E minor. That is obviously the electron. Okay. Question C. State one feature of Rutherford's atomic model. Okay. Rutherford's atomic model and feature is very, very simple. Now, Rutherford's atomic model says that the atom, one of the features says that the atom consists of a small, dense, positively charged nucleus. Okay, positively charged nucleus. That is why I say it is nucleus, surrounded by electrons. Surrounded by electrons. At that time, there wasn't about ilikuwa hakuna hizo nini neutrons wala nini. Surrounded by electrons orbiting at a distance. And that's why kuna empty spaces, mostly empty spaces. So, yep. Now define the term isotope. Isotopes are atoms of the same element with different mass number or with different number of neutrons, or let's say with the same number of protons but different number of neutrons. Okay. Ukitaja instead of protons, ukitaja atomic number, you're not that wrong. Neutrons, but they're neutrons, utaje mass number, also you're correct. That one use of isotopes to disema here in our lesson, especially is used in carbon-4 dating, carbon-14 dating. Okay, especially mambo na fossils hizo. Treatment of cancer, tulitaja hii treatment of cancer, and detecting leaks in underground pipes. Nimekutajia hata 3 uses now. Detecting leaks in underground pipes. Question 2. A grade 10 learner from Chawait Senior School tested the pH of 5 substances A, B, C, D, and E using the universal indicator. He recorded the results in the table below. Which of the following substances is likely to be? Kuna A, substance A, B, C, D, and E. A iko na 10. So ikiwa na pH ya 10, obviously is a base. A very strong one, by the way. 14 also base, strong, but it's very stronger compared to, I think it's E10 iko hapa, strong or weak? I think it's weak. Yes, weak somewhat. It's weak. Then weak. Then we have 14, which is very strong. Then we have 1, which is this is now very strong. It's strong. Yeah, strong. Yeah, strong acid. Then we have this is neutral, and this is also best weak acid. Okay, which of the following substances is likely to be sodium hydroxide? This is an alkaline solution, a very strong one, and therefore the answer is B. Pure water. Pure water, the neutral substance, and that is why the answer is D. So it's not that hard. Then we have a lot. We have tomato juice. Tomato juice is E, pH 4, kwa sababu somehow very weak acid. Not that iko na acidity lakini si strong hivo, so it's E. Hydrochloric acid is a strong acid, and therefore it is C. Now, and then another question, state one product of acid plus metal reaction. If you take a metal, react it with an acid, you get a metal salt plus hydrogen gas. So let's say one of the products is hydrogen gas, and also metal salt is a product as well, or a salt. So you can either write hydrogen gas and a salt. Sorry for that. So yeah, distinguish between strong and weak acid. Strong and weak acid. Strong acids, okay, they have a pH around 1, 2, 3. Weak acids, they have a pH that are greater than 3, so it's around 4 to 6 maybe. Okay, but now if you want to yani kutoa ile definition yake yenyewe, strong acids in short, they ionize fully in water. Ionize fully to produce hydrogen ions, or ionize fully in water to produce hydrogen ions, and this one ionize partially or partially ionize in water, so itatoa less hydrogen ions. So this one itatoa more hydrogen ions, this one itatoa less hydrogen ions. So that means partially. Okay, question 3. The grid given below represents part of the periodic table. Study it and answer the questions that follow. The letters are not the actual symbols of the element. What name is given to the family of elements to which A and C belong? A and C. Remember, hii ni group 1, 2, hii hapa ni transition metals, 3, 4, 5, 6, 7, and group 8. Now group 8 are called inert gases, or we call it rare gases or noble gases, but the main ile chemical name yenyewe wacha tuite noble gases. Okay, noble gas family. Write the chemical formula of the sulfate of element D. Element D iko katika group 1, so valency ya D, the valency for D is 1. The valency for sulfate is a radical, the valency for sulfate is 2. So at the end of the day, D itachukua 2, sulfate itachukua 1, and therefore it will be written as D2SO4. Which letter represents the most reactive metal and non-metal? So which letter represents the most reactive metal? Ukiangalia, the most reactive metals are normally group 1 elements. So katika group 1 elements, the one with the largest atomic size, which is Y. Kwa nini iko na large atomic size? Ni kwa sababu iko na a lot of energy levels. Iko na energy level at least 1, 2, 3, 4, 5 energy levels. Na The larger the atomic radius, the longer the distance between the outermost electron to the nucleus. And if the distance is longer, then it means that the electron is loosely held by the nucleus, and as a result can be lost easily. Now, reactivity is all about losing or gaining electron easily. So if you lose easily, so it means that it's going to be more reactive. So metal Y is the most reactive. Then we have non-metal. The non-metal, ukiangalia non-metals, that is usually more reactive at the group 7 non-metals. So between E and M, ipi ni more reactive? E ni ndogo, it has a smaller atomic radius. M ni kubwa, it has a large atomic radius. Now, non-metals is all about gaining electricity. So if the distance from the outermost, or the distance of the incoming electron to the nucleus is very small, it means that, what does this mean? It means that electron can be gained easily. Sawa, kwa sababu distance ya incoming electron and the nucleus is very small, so the nucleus will attract the incoming electron much easily. And if it attracts much easily and non-metals gain electron, if it gains electron easily, it is more reactive. Lakini hii ambayo ni kubwa, the distance is larger na iko mbali na nucleus, hata ile incoming electron ikiingia na kuna electrons nyingine hapa ndani, ita repel ile incoming electron and it is going to be less reactive. So again, reactivity in terms of gaining electron ni ile ambayo iko na small atomic radius. Ile ambayo ni ndogo is more reactive, and therefore E is the one which is most reactive. Roman 4, select one element that belongs to period 4. Period 4. Select one element that belongs to period 4. Periods ni in terms of rows 1, 2, 3, 4, and that element is D and M. So one element that belongs to period 4, D and M. So if you can write any D and M. Explain why the ionic radius of element E is bigger than the atomic radius. Element E iko wapi? Element E, which is element E iko group 7 na iko katika period 2. So element E group 7 period 2, and how do you write this? Tutaiandika kama 27. Sawa. Now element E ni 27. Element E kama ni atom ni 27. Kama ni ion yamaanisha ita gain electron to become E minus, and therefore is going to become 28. So originally hii ni atom, hii ni ion. Originally ilikuwa ni 9 protons and 9 electrons. So kulikuwa na attraction. But sasa hii kwa vile imegain electron, itakuwa sasa 9 proton versus 10 electron. Sawa. Now the one electrons itakuwa nyingi when it's an ion, na ikiwa ni nyingi when it's an ion, yamaanisha itavutwa ndani. No, haitovutwa ndani, itakuwa positive ziko kidogo kuliko negative. Kwa vile electrons ziko nyingi, they will repel away from the nucleus, na ikirepel away from the nucleus itakuwa kubwa zaidi, na hii hapa atomic radius ni ndogo. Sawa. So the reason is very simple. As it gains electrons, it means that the nucleus, the strength in the nucleus of the atom, of the element will decrease. Ikiwa ni ion sasa, ile nucleus ilikuwa na strength ikiwa ni atom, but sasa ukigain electron, the strength of that nucleus decreases, and if it decreases, the electrons will pull away from the nucleus and becoming larger in size. Very simple. Now element E reacts by gaining an electron, thus increasing its radius. So gain electron itaongezeka radius kwa sababu ya due to the repulsion between electrons. That is why the radius increases, repulsion between electron. Ikiongeza electron, the electrons itakuwa repelled and the radius gets increases due to the repulsion between electrons. Alas. Roman 6. The electron configuration of a divalent anion of element N is 288. Divalent anion is 288. Sawa. Indicate the position of element N on the periodic table. Divalent ya anion yamaanisha ni kama hivi N2 minus. So ilikuwa ni 288. So element N yenyewe ili gain 2 electrons. So originally it was supposed to be 286. Ikiwa ni ion ni 288. Ikiwa ni atom ni 286. Originally ilikuwa 286 but ikagain ndo ikaform N2 minus which is 288. So element N itself is 286 which is period 3 1 2 3 group 6. So jo hapa period 3 ni hii, group 6 ni hapa. So element N ni hapa group 6 period 3. How do atomic radius of I, radii of I and C compare? I and C compare. Now atomic radius of radii of C, radius of C is smaller than I. Tawaambia kwa nini. Atomic radius of C is smaller than I. So the reason why takueleza. Ukiangalia element C, the elements I, let's start with I then C. Element I and C, they both belong to the same period. Zote ziko period 3, period 3, period 3. But moja iko group 3, nyingine iko group 8. Now across the period, the number of electrons, the number of protons increases, sio? The number of protons increases across the period. Na number of protons iki increase, yamaanisha the nuclear forces of attraction will also increase and the electrons will be pulled towards the electron much easily. Na zikiwa pulled towards the the electrons will be pulled towards the nucleus much easily, or it will be strongly held. Ikiwa pulled towards the nucleus, ikiwa energy level yako ni hivi na itavutwa ndani, yamaanisha ile radius itaanza kupungua. So the reason why the atomic radius decreases is due to the increase in protons, which causes the energy level to be drawn towards the nucleus. Sawa, ukiwa na protons nyingi, kwa sababu hapo ukiona hii ni it's around 283, so it's supposed to be 13 protons. Hii ukiangalia ni 18 protons. 18 protons ni nyingi kuliko 13 protons. So and therefore C energy level yake itakuwa much pulled kwa sababu the nuclear forces of attraction itakuwa very strong. Sawa? So let's see, atomic radius of C is smaller than I, and the reason is very simple, because atomic radius decreases across the period due to increase in protons. Ukiandika hivi sawa, or nuclear force of attraction, which results into the increase in nuclear force of attraction. Okay, question Roman 8, explain the trend in the fast ionization energies of the elements J, I, and L. Ji and L. Okay, tulisema, what did you say by the way? Tulisema Ji and L. Explain the trend. Right. Explain the trend in the fast ionization energies of the elements Ji and L. So J ni hii. Siku hizi niko na gas nyingi. Don't know. So Ji and L. But before that we acha tufute kidogo tu. So Ji and L. So ionization energy. Yeah. Now what happens to the ionization energy? Now ionization energy hapa, does it increase or decrease? Right. Does it increase or decrease? Now kwa vile protons zitaongezeka, ionization energy tends to increase. So it increases from J to L. The reason is kwa sababu ikiwa na protons zitaongezeka, na zikiongezeka, so let's say 12 protons, 13 protons, 14 protons, hii ambayo iko na 14 protons itakuwa na a huge nuclear force of attraction. Sasa zile electrons zitavutwa ndani, na zikivutwa ndani sana, inamaanisha zile electrons kuzitoa, you require a lot of energy, and we know that ionization energy is the minimum amount of energy to remove the outermost electron. So ikiwa ni ngumu kuitoa, it means that you'd use a lot of ionization energy. So it increases from J to L due to increase in nuclear charge. Across that increase in nuclear charge. As simple as that. Let's go to the other question. Now, at Malava Girls Senior School, learners modeled more bonding types. Draw a diagram to show bonding in an ammonium ion. N ni 7. So yasema imeandikwa 7, so it's going to be an electronic configuration of 2,5, na hydrogen ni 1. So nitrogen kwa vile ni 2,5 requires at least 3 pairs. Sawa? Na hydrogen at least kwa vile ni 1 requires 1 pair in its outer shell. So tutakuwa na NH plus 4, ammonium ion si ammonia, so it's ammonium ion. Lakini kumbuka hii NH plus 4 imetokana na NH3, then uka add H plus ndo ikaform NH plus 4. So lazima mwanzo ujue vile kuchora NH3. So NH3 itachorwa hivi N, then that is NH3, one hydrogen, the other hydrogen, and the third hydrogen. So kwa vile tumesema it requires 3 pairs, kama unataka kuchora NH3, one hydrogen will require 1 pair, the other hydrogen will require the second pair. So each hydrogen will require one pair. So this is another pair. So nitrogen itakuwa na 3 pairs. Now kwa vile nitrogen tayari ishatumia 3 pairs or 3 electrons in bonding, itabakia na 2 electrons nje, 2. Now it had 5 electrons outside. It was originally 5, then you subtract 3, is going to remain with 2 electrons outside. So hizi 2 electrons ziko hapa. That is NH3. But kwa vile wa react na H plus, na H plus ni an ion with 0 electrons, haina electron yoyote. Sasa itashare vipi kama haina electron? Na for it to be stable ama to be stable ama to be full, lazima sasa ipate 2 electron. Sasa hizi 2 electrons zitatoka wapi? Hizo 2 electrons zitatoka kwa nitrogen. Kusie nitrogen alibakia na 2 electrons, so itashare na hydrogen plus, which is this one that I've drawn, and again that is NH plus 4. Wacha nichore vizuri. So this is the H plus, and you'll show it show the that charge. So this is NH plus 4. So now question B, identify the bond in NaCl. NaCl, sodium is a metal, chloride, chlorine is a nonmetal. The bond between a metal and a nonmetal is called ionic bond, kwa sababu moja ita lose, nyingine ita gain. Ile ikilose itakuwa ni plus ion, ile ikigain itakuwa negative ion, na positive na negative zitakuwa bonded with the help of electrostatic forces of attraction, and the bond now, that bond that will be formed is now called ionic bond, because it's a bond between two ions, the positive ion and the negative ion. Now, state one property of ionic compounds. State one property of ionic compounds. One property is that it has high melting point, so bond zake is equal very strong, and the electrostatic forces of attraction between those ions is also strong. So high melting and boiling point. The other thing is it dissolves in water because it is polar. Dissolves in water because it is polar. Is polar. And that thing, it conducts electricity in two states only. It conducts electricity in aqueous and molten state. Does not conduct in solid state. And the reason why it conducts in aqueous and molten state because of the free mobile ions, not the localized electron, but free mobile ions. Distinguish between ionic and covalent bonds. Ionic involves not sharing but transfer of electrons. Moja itapata, so it involves one losing electron, the other one gaining. So transfer of electrons. Covalent, it involves sharing of electrons. It involves sharing of electrons. Question E, state one use of metallic bonding materials. There is 1 mark. State one use of metallic bonding material. What is its use? First use, it is used in electrical wiring because sana sana metallic bonds are usually conductors. So electrical wiring like copper, because they are conductors, they localize electron. And the other one is it can be used in construction because they are very hard and very strong, like for example iron or steel. Let's go to now section B. Section B, a student in Starehe Boys Center prepared a salt using acid and base. They conducted the following reaction. HCl plus sodium hydroxide gives you what? Acid plus base gives you salt and water. A neutralization reaction. So itakupa a salt called sodium chloride. Is it balanced? Yes, it's balanced. Name the salt formed, called sodium chloride. Instead, the type of reaction is called neutralization reaction. Neutralization reaction. Identify two types of salts. The two types of salts, we have normal salts. Identify two. Ujambi explain. We have normal salts and we have acidic salts, acid salts. Our basics, we also have basic salts or double salts, whichever that you want. Kuna basic salts, double salts. But for now, this question, watacha tu niandike basic salts and double salts. State one use of salt, obviously, in flavoring. Hiyo kitu. Preservation first. Kwa mfano kama unataka kupreserve fish, utaweka chumvi ndani yake. So food preservation, seasoning, and we use it in soap manufacture. Many salt are used in soap manufacturing, and we have a lot of other uses, kuna nyingi sana. Okay, question 6. At Kakamega Senior School, learners tested hydrochloric acid with metals. So acid plus metals, you will get metal salts plus hydrogen gas. So if you have zinc plus HCl, utapata zinc chloride, which is a salt, which is aqueous, plus hydrogen gas. Balance them na chlorine mbili, hydrogen mbili, utaweka tu hapa. Ni sawa. Identify the gas produced, that is hydrogen gas. I did describe two properties of acids. Acids are usually, they have a sour taste, not a bitter, but a sour taste. Bitter ni basic, and they have a pH below 7. pH below 7. And again, another property is it turns blue litmus red. Turn blue litmus paper to red. And khalas. Simple as that. Kuna zingine, but just revise. Get this. Write two reactions of acids with metal oxides. Okay. Now, if metal oxides, which is a base, reacts with acids, okay, or two reactions of metal oxides, yani ya kupa nini tuipe mfano. So let's say copper oxide, which is solid, plus HCl, is aqueous, is going to give you copper chloride, which is CuCl2, kwa sababu copper to chloride, copper ni valence ya 2, chlorine ni valence ya 1, and therefore you're going to get copper to chloride plus water. Plus water. If you take a base reacted with an acid, you get copper chloride. So is it balanced? No, it's not balanced. Itabidi sasa tuweke 2 hapa. Ikiwa ni 2 hydrogen, hapa pale ni 2 hydrogen, 2 chlorine, 2 chlorine. Carbonates. So acids with carbonates. Now the best one is calcium carbonate. So let's take calcium carbonate. That's the carbonate plus HCl as well. So itakupa nini? Itakupa calcium carbonate plus HCl. Carbonates, if you react with acid, you're going to get metal salts plus CO2 plus water. So utapata calcium carbonate, calcium valence yake 2, carbonate valence yake 2, and therefore hii 2 na 2 yatoka, ndo maana itakuwa CaCO3 plus carbon 4 oxide, which is gas. This one is solid plus water. Now let's balance them. Okay, CaCO3 plus CO2 plus water. Itabidi hapa tuweke 2 kwa sababu hydrogen is less on the left side. So 2 chlorine, 2 chlorine, sorry, calcium carbonate. Sorry. It's supposed to be metal salt, which is calcium chloride. Calcium chloride ni CaCl2. Sorry for that. Ndo maana nashangaa. Where is the Cl? So calcium chloride. So 2 chlorine, 2 hydrogen, and then 1 carbon, 3 oxygen. 3 oxygen is balanced. I think that is balanced. Nahitaji another balancing. Question D. State one use of acids in industry. State one use of acids in industry. Acids can be used in flavoring, by the way, but they can be used as in fertilizer production. Fertilizer production, also in car batteries. So خلاص. Naona rahisi sana. Okay, the table shows the results of adding 3 metals PQ and R to dilute hydrochloric acid and to water. If you're seeing this PQ and R, so if you take P, add it to dilute HCl, you're going to get hydrogen gas. And if you add it to water, then you get hydrogen gas. If you take Q, there's no reaction with dilute HCl. Also no reaction with water. R, hydrogen gas produced, but no reaction with water. So what is the order of reactivity of the metals? Now, the one that usually reacts the most, ile ambayo ya react sana, tamam, ndo ile ikireact na zote mbili is the most reactive. Okay, order of reactivity, P is more reactive, followed by R, which is more reactive than Q. So hivyo tu. Zikireact na zote mbili yamaanisha that's the most reactive. Ikireact na moja haita react na nyingine, that's the second reactive, and kama haireact na yoyote, that's the least reactive. Study the information provided, explain why the melting point of oxide of W is lower than that of the oxide of Z. Ukiangalia atomic radius, W, Y, and Z, is it the same thing? No, different. W, Y, and Z, atomic radius, hii ndo kubwa. But why the melting point of the oxide of W is lower than that of oxide of Z? W ni hii hapa, hii ndo Z. So why? I think it's very simple. Now you look at the atomic, I think the reason is moja iko na simple molecular structure and the other one has giant ionic structure. And how do you know that? You just look at the melting point, obviously. Now he, obviously, for molecules, the ionic radius becomes larger because it gains electron. Ikigain electron, yamaanisha itakuwa na electron repulsion. That is why this is a non-metal. Okay. For metals, ionic radius is usually very small compared to atomic radius. Unaona hata hapa. Because metals usually lose electron, and if they lose electron, they also lose the energy level, and this shows that this is a metal. Now, metals usually have a high melting point because of giant ionic structure, and non-metals have a low melting point because of simple molecular structure. So oxide of W has simple molecular structure, ndo maana melting point yake iko chini. Structure, while that of Z has giant ionic structure. خلاص tunaona rahisi sana. Let's go to question 8. Alana in Mary Hill Senior School prepared copper sulfate crystals. Describe 3 methods of preparing salts. So 3 methods of preparing salt. I think this is describe 3 methods of preparing salts. First, describe yan. So first you take acid, reacts acid with a metal. So that's the first method. Reacts acid with a metal, you get metal salts. So now hapa isema describe, but it's just 3 marks. The second one is neutralization reaction. So you react acid with a base for metal salt pia, and the last one is precipitation reaction. So precipitation reaction ni react 2 soluble salts ambao 1 soluble salt will become a precipitate, e.g. Lead nitrate and sodium carbonate. This one, e.g. zinc plus HCl, na hii ni maybe copper oxide plus HCl. خلاص. Explain behavior of salts in air. Behavior of salts in air yaweza kuwa ni deliquescence. Deliquescence yamaanisha it absorbs water or absorbs moisture to form solution. Absorbs moisture. The existence of a salt that can absorb moisture to form a solution. What about efflorescence? Efflorescence, it loses water to atmosphere. So efflorescent salts or efflorescence is just the ability of losing water to the atmosphere. The liquescence absorbs, like on a hygroscope. Hygroscopy absorbs water, but it becomes damp. It doesn't form a solution. Now, state two uses of salts. Again, the same thing is repeating itself. Okay, one use of salts is that uh, salts like salts uh, such as sodium chloride is used in flavoring the food. Is used in flavoring food. Ya pili ni salts like ammonium nitrate can be used as a fertilizer. Is used as a fertilizer. Ni hizo tu. Okay. Question 9. The table below gives information about ions of P and Y, which is that. So P and Y. P plus ilikuwa ni 28. So it means it lost electrons when it was atom. So now add the 2 electrons back, it's going to be 282. So from P to P plus, no, it's not 282, it's supposed to be 281. So from P to P plus, it may lose 1 electron. So P, it lose 1 electron to give you 28. For Y2 minus, ni 288. Sawa? But now originally, yamaanisha kuwa the atom gain electron, and therefore originally ilikuwa ni 286. Ndo maana ika gain to give you Y2 minus. So write the electronic configuration of the atom of Y, and that is 286. How many protons are there in the nucleus of P? How many protons? P, atom yake ni 281. It means it has 11 electrons. In a neutral charged atom, the number of protons is equal to the number of electrons. Kama iko na 11 electrons, itakuwa na 11 protons. The atom of Y is 16 electrons and therefore 16 protons. As simple as that. Write the formula of the compound formed when P and Y reacts. So P tulisema ni P plus. So P iko na valence ya 1. Y tulisema ni 2 minus, valence yake ni 2. So ita form P2Y1. So the answer is P2Y. Alas, 2 marks hizo. Lakini lazima uoneshe vile ulivyopata. State 2 uses of sodium. Is used mostly in street lighting. Sawa. Ya kwanza. Ya pili, nuclear reactor coolant. Nuclear reactor coolant is used as a coolant in nuclear reactors. Yatuliza. Now, identify one safety precaution when handling alkali metals, because some alkali metals are very explosive, kwa mfano potassium. So make sure you handle it with forceps. Usichukue tu kwa mkono then uibwage tu kama boli. Handle with forceps and store it under water. Otherwise, kama store it under oil, kwa sababu ukistore under water ita react na ile water and then khalas kusha, there will be explosives. Ndo maana the best way to store is under oil because it's somehow unreactive with it. Study the structures of substances L and M shown below. Okay, complete the table by giving the names that describe the type of structure and bonding in each substance. Now this one is sodium chloride, and this structure is giant ionic structure. Sodium chloride najua tu ni giant ionic structure. Well, nikiona tu kama ka cuboid najua tu hii ni sodium chloride, which is giant ionic structure. And this one is tetrahedral structure. And coming in tetrahedral structure, obviously there's a possibility of 2, so most likely in diamond. And this structure is giant covalent structure or giant atomic structure or giant molecular structure. I think so. Now, complete the table below by giving the names that describe the type of structure and bonding in each substances. So L, the structure is giant ionic structure, but the bonding ni ionic bond. Well, M ni giant covalent structure, or giant atomic structure, whichever. But bonding ni covalent bond, obviously. Question 11. The atomic numbers of nitrogen and fluorine are 7 and 9 respectively. Draw dots and cross diagrams to illustrate bonding in the molecules of nitrogen and also fluorine. Now nitrogen is 7, so it's going to be 2, 5. Fluorine is 9, so it's going to be 2, 7. So here nitrogen is written as a nitrogen molecule. Now it's di. So here I require 3 pairs of electrons. So again, let's draw this. One nitrogen bonding with another nitrogen. So you require 3 pairs. So kila moja to 1 pair, first pair, second pair, and third pair. Now I'm drawing X dots to differentiate between the first nitrogen and the other nitrogen. So 2, 5, and if you remove 3 electrons, going to remain with 2 electrons outside. So kila moja itakuwa na 2 electrons, 2 electrons. So this is triple bond. This is now called triple bond. Now let's go to fluorine. Fluorine is much likely the same. Hii fluorine lakini yahitaji only 1 pair. So fluorine will be this way. Then this. So another fluorine. So 1 pair. So dots and an X tosha. And ikiwa ni 1 pair, so it's going to remain with 7 minus 1 is going to remain with 6 each of them. Hii itakuwa na 6. 1, 2, 3, 4, 5, 6. This one also 6. 1, 2, 3, 4, 5, and 6. And that is the answer. So some people usually use this, which is also correct ikiwa utachora kitu kama hivi, okay, and which utaonesha lakini. So some people usually draw it like this, which is also correct. Wengine pia watafanya hivi, x dot, then another x dot, another nitrogen, then hivi, then hivi. Or if you want, waweza kuchora hivi hapa. Heri mimi nichore hapa pia. So hopefully that is correct. With reference to the diagrams, in A, states why fluorine is more reactive than nitrogen. That's why fluorine is more reactive than nitrogen. Now fluorine, or let's say nitrogen, has triple bonds. While fluorine has a single bond. Ukiangalia vizuri, nitrogen iko na triple, iko na 3 pairs. So while fluorine has single bond. So, and that now makes, so single bond is weaker and much easier to break. Single bond is weaker, and if it's weaker yamaanisha iko rahisi kureact. Is weaker than the triple bond, hence easier, and if it becomes easier to break, it becomes easy to. So, Question 12. I think we're very, very close to finishing this paper. At Maranda Senior School, learners study chlorine isotopes. Define relative atomic mass, which is something that I've repeated every time and then. Relative atomic mass is the weighted average mass of an atom, or the average mass of an atom compared to 1/12, compared to 1/12 of carbon 12. So calculate relative atomic mass of chlorine. Haya, umepewa hapo kwenye hii swali 35, percentage yake ni 75%. Hiyo nyingine chlorine nyingine 37, percentage yake ni 25%. So it's just the same. Utachukua mass number 35 times its percentage abundance, which is 75, add it to the other mass number times its percentage abundance, which is 25, divide by 100. Let's see how much is it going to give us. 35 times 75 plus 37 times 25. So yeah, you itakupa 3,550 divided by 100 is going to give you 35.50 or 35.5, and that is the answer. Last question. A factory in Nairobi, okay, a factory in, not the last question. Kuna swali lingine nimesahau. A factory in Nairobi industrial area produces fertilizers and detergents. Explain 3 uses of chemistry in daily life, obviously used in making medicines. So one of the uses, manufacture of medicine, obvious, manufacture of medicines. Ya pili, enhancing agriculture of our nation. Also can be used as in cleaning agents, in making of cleaning agents or detergents. Okay. Question B, state 2 environmental effects of chemical misuse. Ya kwanza utatokea na water pollution, which will cause the living fish to die. If the water is polluted, either you'll die or the fish also underwater. So especially uki discharge chemical into the rivers, and the river is concentrated with a lot of chemicals, the plants will grow, and once it grows now sasa ita deplete ile oxygen and leads to suffocation of the fish. Now the other thing is also global warming. Hiyo ni kitu kingine. So chemical misuse, especially when you discharge chlorofluorocarbons to the atmosphere, it destroys the ozone layer, and as a result it can cause global warming. Suggest 2 safety measures in chemical handling. So when you're handling a dangerous chemical, always wear a PPE, protective clothes. So wear PPE and ensure ventilation, because some other chemicals are very toxic if you breathe in it. So that is why dangerous chemicals are usually done in a fume chamber. Ukiona chemical ambayo is released as a gas, we don't smell it directly, we just waft it. So ukismell huwezi jua, waweza kufa pale. The last question is question 14. Ethanol is liquid at a room temperature but does not conduct electricity. Explain. Now ethanol, which is C2H5OH, has a simple molecular structure, and simple molecular structure do not have the localized electron. Does not have the localized electron, and therefore do not conduct electricity because it lacks free ions or the localized electron. So ethanol is a simple, or is a molecular compound. Let's just say it's a molecular compound, or has a simple molecular structure. Is a molecular compound and does not conduct electricity. Does not conduct electricity because it lacks free ions or the localized electron. Hopefully that is understandable. So yeah, so let's stop it there. I think that is all for today's lesson. And again, don't forget to subscribe. In case you need other papers, just tell me. This is my number. Hopefully I'll upload the business paper as well if ipata time pia biology paper. But don't forget to subscribe, and I'll be starting my own my tuition classes with the help of another teacher as well. So in case you want to get admitted into that tuition classes during these holidays, contact me through this number and I'll upload. So just be patient. I'll upload other videos on maths, grade 10 lessons, also on chemistry, grade 10 lessons, and business grade 10 lessons. So I don't have much to say. Assalamu alaikum and peace out. What does peace out mean?